Let's do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. Find us on the web at gotime.fm, on the Fediverse at GoTime, at changelog.social, and on X at GoTimeFM. Thanks to our partners at Fly.io, the home of changelog.com. Launch your app as close to your users as possible. Find out how at Fly.io. Okay, here we go.
Hello, listener. Welcome to another episode of Go Time. Yeah, you guys like the dramatic pauses in between.
This is now a true crime podcast.
A true crime podcast. Yeah. Yes, and joining me as suspects, or I don't know, co-hosts. I mean, depending on how you look at it, is Ian Lopshire. Ian, how are you?
I'm doing great.
Good to hear it. And also returning after a hiatus. Well, I guess not so much of a hiatus now, because you did do the live episode from GopherCon EU, right? Matt Ryer, welcome.
True. Hello. Yeah, I did do that. That was fun.
That was fun.
You were there, Johnny?
Yeah, I was there.
Yeah, you were on it.
Having my delicious alternative to brushing my teeth. Good old coffee.
Delicious.
Yeah. Deliciousness.
No, but a lot of people, I said that joke, and I said coffee is a delicious alternative to brushing your teeth. I've had messages, people telling me, no, you do still need to brush your teeth. So please, just pass that on. If anyone asks, you do still need to brush your teeth.
Yes, those things are not mutually exclusive.
Yeah, and also everyone, you can stop messaging me about that now if you like. That's fine. Also fine.
Oh man, that's funny. Yeah, you shouldn't have made that joke. Now people are gonna chase you down. So
yeah,
what is not a joke is this article. You keep writing and rewriting and updating and refreshing every couple of years about writing HTTP services now in its 13th year. And what was it, second or third refresh? Is that it?
Yeah, I think it's the second refresh. There was an early version, and then I did a refresh of that. Mm-hmm. And it's the same thing. I just update the title with the different number of years that have passed. It's the gift that keeps on giving.
Yeah, Keep.
When was the first one?
Oh, I don't know.
The first one I encountered was 8 years. Was there one before that?
I think that was the first. There may have been a 7 years, and then 8 years was the one that was there for a long time, because it didn't really change much. And then I felt like enough had evolved that it was time to do a refresh and give it a new life, I suppose, a bit.
Mm-hmm, mm-hmm. So obviously the link to the new one, which actually contains the links to the old one, right, will be in the show notes. But yeah, Ian and I were thinking, we'd kind of go through and call out the interesting bits. So what were the sort of the major changes, right, with this refresh? What was sort of different? Why did you change the approach?
One thing that changed was preferring HTTP. I used to prefer HTTP handler func. So I would use that type everywhere. And then at the points at which you needed to interface with HTTP handler, you can, right? Because it does implement that. But then if you're taking sometimes it made bits easier to write, but actually made it whenever you had to interact with third-party languages or third-party libraries, you then had to do extra gubbings in places, and it just kind of looked quite ugly. So I think I just decided I'll just go to HTTP handler because that's the simple type. Tom Wilkie, also, who's the CTO at Grafana, also said that same thing to me a long time ago. Actually, I met him in an airport. We were both on our way to a conference in Lviv, actually, in Ukraine. And we'd missed a connection. And then there was just like a person talking behind me in the queue about Go, and I can't resist that. I can't just let that happen. Mm-hmm. If they say something I don't agree with. So I spun round, and then that's where I met him. That's actually where I met him. And that led to now I work at Grafana Labs. So I don't know. I don't know how many people you're meeting in airports, but get to your local airport, I say. You never know what's going to happen.
Find yourself a job. You can go to your local airport to find a job, That's how I'm connecting those dots. Okay.
Yeah. You do have to miss a connection, I think.
Right. But do you think you have to be headed to Ukraine for that to also align things for you?
Good question. I've only done it that way, so that works for me. I suggest you do exactly the same. Yeah, don't change anything.
Might not be worth it right now.
Yeah, true.
Right. Indeed. So away from handler funk and embracing the good old HTTP handler interface. And obviously you added some additional opinions to the testing stuff, and we'll get to that. But yeah, I was looking through the examples that you had on the blog post, this new server constructor and all these arguments. Yeah. So I think if we deviate slightly from the HTTP services sort of conversation and talk about sort of how many arguments, right, should function signatures have and support. The reason I'm calling this out is because I've been a part of many language communities where there's an optimal, right, number that you should have, and if you go beyond, then you get a side eye from your fellow developer kind of thing.
Right. So this comes from I used to have a server struct that would have all the dependencies in there, and then the methods would hang off that server type. And that meant you could just put dependencies like the logger or a database connection thing. You could just put those into the struct, and then they're available to all of your handlers. So that was kind of a nice convenience. But actually, what I found over time was when you come to actually write a test for it, one of the nice things about a list of arguments is it's very clear what this thing needs. And even if in your test, it's not gonna be used, you can explicitly mark that with a nil. You pass a nil in usually or something. So when I would do that, and sometimes it would still fail, and it would fail because it was using a dependency that I didn't remember because it was in the server struct, and there was nothing to prompt me to do that. So I had to live through the panic, and that was all really. It's not the end of the world. Like a lot of this whole blog post is kind of personal taste and things that work for me, but this led to then you have a server constructor that takes in loads of arguments sometimes because it's all your dependencies are going in there. Your logger, some config, you might have some database stores, you might have loads of various services. If you're sending email, you might have an email sender service kind of thing, or a comment service. And depending on how you structure it, you can end up with these long argument lists. And so that's the question is, do you like long argument lists? Is there a limit where you think this is silly, I'm going to put it in a struct? Do you just always go for a struct wherever you can immediately and just be done with it?
I've done it a few different ways. And I think I will sort of tilt one way or the other depending on sort of how explicit I want to be or not be with things that can be nil, or the things that have defaults sort of within a struct, right? So my personal preference in this particular case would not be to have a new server with all these things I can pass in and sort of passing in nil when I don't need something. I might perhaps, in this particular case, choose the sort of functional options pattern. Basically, and for those who are not familiar, it's typically you'll invoke your pseudo constructor, if you will, and then you can have sort of a with some with options, right? With a router, with a muxer, with a store, with a whatever it is. And then pretty much internally, whatever the defaults are for the things you don't specify, right? They can kick in sort of automatically. And you're just specifying a with sort of option for the things that you do want to override. So I tend to prefer that approach as opposed to having long argument lists where I'm sending nil for the things I don't need.
Yeah. So that is nice because you aren't in that world. You don't mention the things that you're not concerned with. So you have good sensible defaults and then use those options to set the specifics that you care about. Yeah, I don't mind that at all either. I know I've heard a lot of people push back against these sorts of, there's a bit of a discovery issue with it. You can't easily just see a list of all the possible options that you can set or pass in. A struct at least gives you that. But so I think, it's kind of trade-offs and taste, I feel like. But I think a lot of this blog post might come down to that. and I might be able to convince you with some good arguments. But if you've got a good reason to not do this, I think I do say this in the blog. If you've got a good reason not to do it, then you've got a good reason. Like, that's it. That's what you should do. Because I sometimes get people sometimes will stick very rigidly to what I've written. And when they're then battling something and it doesn't quite fit, then they'll sometimes reach out, and there's just a much easier, usually there's just a much simpler way they could have done this. And they were kind of bending over backwards to follow the advice. But, that's just all part of, I think, learning and, using these sorts of blog posts properly, which is not really to take them literally, but to get ideas from them and apply them in your case where it makes sense.
With this long list, what's like the max you've encountered, and were you okay with it? Like, like if we ran this way, we run like a pretty big monolith, and there would be 50 things in this, right? And that's just not doable.
50 I've not seen. I think honestly 15 to 20, and I was okay with it. But I should say I tend to format it differently as well. So it's not like like GoFumped also doesn't mind this, but you can basically just put each argument on a new line. So it's just like a list, like a bit like when you do a variable list and or even a struct when you're declaring lots of things, you kind of have an indented list of items. So in that way, it's not that different from using a struct. It's just that you are forced to provide. You're forced at that point to provide an answer. And when you come to changing things and you're getting the compiler giving you warning errors, it won't build because this signature's wrong. That's very brutal, but that is really how you find all the places. And as soon as you fixed all that, everything kind of works. Assuming you've got all your dependencies of different types, so you can't end up with mixing the order up or something, which would be an absolute nightmare. Assuming that they're all your own type, that is really nice. You get that help. So I tend to work in an environment where things iterate a lot and change a lot. So I kind of optimize for changing things, and then anything that helps me guard against mistakes. It's why I'm so big on testing, honestly. Like that becomes more important. I sort of optimize for that. Not always, but mostly. Are you still doing the detective thing? Is that still happening, Johnny? Like, it's going to be like Exhibit A, that was, and now. And then, Ian, really, you should be bad cop. If you can.
Ian.
I don't know if I could be bad cop on this. I don't know.
No, you can.
I tend to agree with most of what you have in these articles. So,
all right, you be good cop then.
Then I'll deliberately go out of my way to be nitpicky and be like, why did you use the variable A here?
Yeah.
Okay.
It's good cop and pedantic cop. This is the new TV show coming soon.
Coming soon.
Changelog TV. Two detectives. This is a good idea.
One protein bar. Before the show, we were talking about Ian's protein intake, which I respect because you gotta get your protein. I think Ian's trying to pack on some muscle, so he's eating his proteins regularly.
Gotta get those gains. Yeah,
you can't leave those gains.
You have a protein bar for breakfast, do you though, Ian?
Yeah, every day.
Yeah,
starts off.
It's like living on the International Space Station. You get up and float to your fridge, and you get out your
packet.
I also have freeze-dried food for almost every day for lunch, so it really is like I'm living in the space station.
You're living the space dream.
Wow! Blink twice if you've been kidnapped.
I don't know if people are getting... Now he's got to try not to blink, so you're not worried, Johnny. Now his eyes are bleeding. His eyes are crying.
Yeah, because I don't know why you deliberately put yourself through such a eating condition, but hey,
I see.
It is cheap and easy.
I like the easy.
It's better than not eat at all. Otherwise, I'll just forget about lunch.
Johnny thought that people were being kidnapped and sent to the International Space Station. It's no one wants to go, so we have to now. We're just kidnapping people.
Yeah, we're just sending them up there.
Because no one can hear you scream, can you? No one can hear you scream.
Yeah, out in space. Yeah. I hear voice doesn't carry.
Yeah.
Anyways,
vacuum.
Speaking of what carry, so you have a routes.go, which I'm looking at it, and you have this add routes, function where you're passing in, your muxer and your logger and any other sort of things you may need. And that's where you sort of do all the mapping for the routes.
Yes.
Which does make sense. Yeah.
Well, there's something nice about having one place that maps your entire API surface. In Go, we tend to group things up by responsibility. And I used to do that where I would have the routes for, say, the comments thing were in the comments service. Like it did its own routing. You pass the muxer in or whatever, and it would wire itself up. That felt very satisfying. But usually, anytime there's an issue or an incident or bug report, usually comes with a URL. If it's an API, especially these kinds of APIs. So it really, I found myself actually starting with the URL. That's how I would, if I jumped into a project I haven't been in for a while, that's how I would go and figure out where to look. Mm-hmm. So I started to have, put all the routes into one place. I also got this, there's a few other frameworks that just do this, just naturally the way they work. And it isn't just nice that you can see your entire API surface. It also helps you you're not looking at the API surface in fragments. You're looking at the whole thing as one. So you get to think about how do these things play together. Sometimes you might say comments here and it's not pluralized elsewhere, or it's called messages in another route or something like this. And that kind of toil when you're trying to consume an API is kind of horrible. So partly this is putting yourself in the place of where the user's going to be, which is they're going to see this API surface as one of the first things they might see. Yeah.
This is something we do, and I think it is the single greatest thing you can do for code navigation, because it's basically an index of everything. So even when I don't have a bug report and I'm looking for a certain functionality, I ended up in this routes file, and I can immediately find what I'm looking for.
Yeah.
See, can't be the bad cop because
no, that's very
I love
cop.
this.
Great cop. That's really a great cop for me. That makes me feel like I'm going to get away with it.
and we
you might not. We
even have a large number of routes, right? We have a pretty big API surface, and even I'm probably up in the hundreds of routes at this point. And even at that scale of routes, like in our big monolith, it's still great. It doesn't get confusing. Like it's easy to break it into blocks of, hey, this is this service, this is this. I would definitely recommend to take this advice.
Good. Ian, do you also do your middleware bits here as well? Or is that elsewhere?
We do that in this, yeah.
Yeah, because that's also quite handy for a similar reason. It's like immediately being able to see the dependencies and the trail of that. There are frameworks that do dependency injection and things where they've given you some kind of configuration, or you can ask for a particular type of a thing and whatever. And honestly, if you're trying to work in that way, you really don't get as much help back from the compiler. Whereas in this, it's just Go code. You're just calling functions. And, you get so much extra free stuff from the tool chain, from everything, just because of that, because it's such a common thing to do. So, yeah, I like to call all the middleware functions in there. Sometimes it gets a bit like there's bits of code you have in there as well that are doing something. Also, quite nice to just have that spelled out explicitly rather than sort of try and hide it somewhere if it's relevant. So, yeah, Johnny, do you do this kind of thing? Do you like to have? How do you do routes?
I do like to group them together, and for all the reasons the two of you have mentioned. One thing that I've started thinking about is I'm a big fan of using a standard library for most things, and even when I had to sort of jump through a couple of hoops here and there to sort of have specific route in small applications to have do my own URL parsing to extract variables or values or something like that, right? I'd opt for using a standard library even if I had to jump through those hoops as opposed to using a framework like the popular ones, the cheese or a gin or whatever that is popular these days. Obviously, with the introduction of sort of the more robust routing library enhancements, right, to the HTTP package from I think 122 or was it 121? now I'm pretty happy about that. I'm pretty stoked. Right, I can still stick to the standard library without having those to bring in those additional frameworks. But those additional frameworks did sort of do the right thing, so to speak, by allowing you to sort of define all your routes in one place. Set up all your middleware in one place. They sort of encourage you in that direction because it does make sense to have all the routing and all the middleware logic grouped together like this. It does make sense.
I just pulled up our routes file, and it is 526 lines long, and it's still perfectly organized and easy to use. So
you sound so proud.
Yeah, but I get it. It's good.
I don't want to say proud. I mean, that's a lot of API surface. I would like not to have that large of an API surface, but things gather cruft over time.
Things happen.
Yes, and you wanted the monolith. You love a monolith, don't you, Ian?
I do love a monolith.
Yep.
I do. Actually, the changes you mentioned in the new HTTP routing stuff, which essentially allows you to put path variables in, and then you can pull those variables out, which is really what everyone was using Gorilla Mux and the others for.
Right.
Anyway, to be honest, when they got into like subroutes and things like this, you can create like a route and then create a subroute, and it's like too powerful, too abstract. We don't really need that. What we need is a list of what look like URL paths, because that's how we think about things. But I think those changes will make me go back, because I used to use Gorilla Mux just by default. I'll go back to just standard library now because of that.
Yeah, I think a lot of folks will. For writing your own middleware, you don't need some other library to help you do that. It's pretty straightforward to do that with good old handler interface and everything else. So there's really no real reason, at least for me, for the kind of applications I build. There's really no reason to depend on a framework at this point for the thing. I mean, and you had additional things like session management, or like some sort of abstraction for cookie setting or whatever, these things. And again, nice. I'm not sort of bashing any of those frameworks. They did provide sort of a nice on ramp, I'd say, if you are used to other frameworks from other languages. But I don't know. To me, it's always been sort of keep it simple. Don't bring dependencies you don't need.
Yes, but the cookie one's a good call out, because I think the standard library, the way you deal with cookies I found that really quite weird.
A little rough. It's a little rough.
Yeah, I mean, it's just very low level. So you learn a lot about how cookies really work and what they actually are. So you know what you're accepting all the time when you go on EU websites. But
right.
I got stuck in the advanced settings of one of them the other day. Couldn't figure out to close it. Just left the website. Yeah, just like, no. I'd literally rather be hacked. It's meant to be there to protect us and stop us being tracked. You know what I mean? But it's not having that effect if I'm tweeting where I am and how angry I am. You know what I mean? That's more information than they would have got.
Is there not like a browser level API that they could build that said like, I accept all, I decline all?
That is no. They literally, because what they thought was going to happen is they're going to stop tracking people now. Like this is put the end of, and it's like, oh, you have to have this annoying thing that ruins your experience of your website, and all the businesses are like, yep, we'll have an awful experience, please. So yeah, it didn't have that effect at all. They're still tracking everyone, and you have to answer every time. If you reject it, if you say no, then it's fair enough that it asks you again, I suppose, because you're told that you're not allowed to remember.
Because you came back.
Yeah,
you came back.
I came back, but yeah, just a browser setting exactly, or some oh my god. Mind you, they also then gave us USB-C on all iPhones and all phones. And they gave that to the world.
Can't be all bad, right?
Yeah, it's not all bad, is it?
Yeah.
Now, if I could just figure out which USB-C cable works for what device, that would be great.
Oh, you're joking? They don't all work for every device?
No, definitely not.
Well, how's that helping?
Is it USB-C? Is it Thunderbolt? Is it? Oh yeah. Can this one charge at what watts?
Right, exactly. There's I think I read something like a link off of Twitter or something, or X, that sort of talked about all the different variations in the protocol, and it was maddening. I'm like, how is a general consumer supposed to know all of this? It was maddening.
This microphone I'm using is USB-C, and if I plug it in with a cheap cable, it sounds like this.
There's not enough throughput. Yeah,
exactly.
That's weird. Is it just that the tube's not big enough for your voice to go in it?
I mean, I think just regular USB should have worked for this, so I have no idea.
No, it's a protein. It's a protein you're eating, Ian. It's
coming through the cables.
Yeah. It's clogging up the pipes.
It's made your voice too beefy. Johnny, you can't really troll him about this because I saw you in real life in Berlin for GopherCon EU, and you're stacked, mate.
Definitely your protein, huh?
I mean, I didn't say Ian was the only one eating his proteins. I mean, at no point did I say that. I eat my proteins too. It's all right, Ian.
Is that all you have to do? Just eat protein? Because I can do that.
Just eat protein. That's all you got to do. Just eat protein. Just eat protein.
Eat protein and sit on the couch.
Sit on the couch. Done. And record a show every once in a while.
Yeah. And you do that dance. Isn't there like a famous dance that you do? The protein shake? I've heard of that, but I don't know. Is it
like the bartender?
Yeah, it's got to be. Yeah.
Yeah, I didn't know that. Yeah, Ian, you just demonstrated the protein shake. Yeah, the bartender. Yeah. That's amazing. That's amazing.
I'm going to use that next time I go dancing, which will be never, but anyways.
let's talk about this run method you really like to have in your code, Matt. So your main,
love it,
right? Mm-hmm. is just obviously your main function, but you don't have much else in there other than this call to run. And this run takes a context and it takes an IO writer and some arguments, a list of arguments. Like what are you thinking? Like you used to have these things inside of main, all like proper. Like what made you split them?
Yes. So the main motivation here comes from being able to return an error, because really like the pattern of like there's this idea of self-similarity all over. Like if the code is the same everywhere, it's kind of in some ways it's easier to deal with. Like if sometimes in main you can't return an error, so your error handling code can end up being 3 or 4 lines actually if you've got instrumentation in there as well, and wrapping and other things. And so if you're in main doing lots of, normally you are setting up, connecting to a database, checking some other service is available, doing whatever you're doing, you can error. And so I ended up having main that just had the same error handling code or very similar, repeated a lot. And, people complain about having to write if error doesn't equal nil. Like that really makes people angry still. It's one of the top things that makes everyone angry. Yeah. It's like, I don't want to have to check if that error's nil for some reason.
You just want to ignore it?
I don't know what they want. I think it's the biggest complaint. They're like, can you just make this automatic because I'm doing it all the time, which I understand. And that was kind of my thing. I had 4 or 5 lines of this stuff, not including the braces. If you add the braces on, it's more.
I mean, yeah.
One more. Yeah. So call out to a run function. And then I found, actually in test code, I can just call that run function. And as long as I don't use anything from the environment that's not passed in as an argument, actually that is a self-contained that's like the program running in a self-contained way. And then now I was cooking with gas because, I could actually write tests that ran parallel, but were essentially running the program multiple times without actually doing that. And then, so I kind of got sold on that. The point is, you take in the arguments, you're taking an IO writer if you're going to write to standard out. You take in the args, even if you're doing flag parsing and stuff, you do all that inside run so that you can, in your test code, you can call your program with different flags just by passing in different arguments. You get, of course, type safety, the compiler will check to make sure you're passing things. So when you add a dependency, say now we're going to read from standard in now, or we're going to write to standard error for some particular case. You update the signature, and then you're faced with a load of errors, which is a good thing. It tells you all the places you need to now go and add something in, whether you're going to null it out or provide a thing, And if you've got, but like the bytes buffer is a really cool type, because just like an in-memory buffer, but it supports IO reader and IO writer. So you can pass a buffer in as like the standard out, and then in your test code you can get the string of what was written and assert that certain things are there. So you can write test code that is even checking things in the environment to make sure that that's as expected. And you could imagine in some cases that's not important. If it's a web server, what you print out usually is just for humans to read. But if you've got a program that is, if it's parsing JSON and writing lines of JSON out or something like that, this makes a lot of sense.
Yeah, I was kind of against this when I first read it. I mean, we do all of our kind of configuration in the main file, right? So we end up with these very large mains that like kind of, I don't know, string everything together that we need. But what changed my mind was this get environment function, right? That you pass in to run. And I was like, oh, that would make a lot of my testing so much nicer. Like the idea of passing what will be used for configuration into this run, I really like.
Yeah, that's a good point. So Ian's talking about one of the types. So it may be that there's a concrete type you're passing in, like the OS GetM is a function. But you can have a function type, since we have structural typing, duck typing in Go. You can just decide your own type. So make a new type and that one's going to fit it. That allows you to then mock it or provide a different function. So if you are reading environment variables through os.getenv, you instead use the passed in getenv function. And in test code, you can just have a switch in there to say, if they're asking for this, return this value. If they're asking for this one, or if it's not one of these, we could even error there. It shouldn't be asking for something from the environment that's not expected. So yeah, I like that one as well. They did add something into testing code for this. There is like t.setEnv.
Yeah, I've been using that. That's been in there forever. I've been using that forever.
Yes, but you can't run them in parallel. I think it is actually setting environment. So it's not the set, you don't get the parallel thing. Whereas with this trick, you can run them in parallel because it's just functions. It's not even actually dealing with the environment.
We use this trick the same with time.now a lot, where you can just have a function that returns a specific date, so you're not depending on the actual time.
Yeah, so you can make your tests deterministic. And sometimes that's really important. Roberto Clapis because I did the same thing with random numbers as well. If you've got a random number generator.
Okay, so I do like that getM function. You can sort of determine depending on the context, how you want that to be handled. I do like that. My current configuration sort of approach that I've kind of used consistently across projects is you just have a config sort of struct with some struct tags on there that specify what is the expected name from the environment. Like I always assume that I'm going to be fetching things from the environment, right? It's like os.getM style. And then I use, there's at least one or two different popular libraries. I think one I use is called envdecode or something. But if anybody just searches for envdecode on pkg.go.dev, they'll find at least one package that does this. But basically, I just initialize my config struct, and all based on the struct tags, all the appropriate values from the environment are sort of read in. So I get a config, basically struct that is fully populated, and you can have sort of validation checks, and you can have defaults, and you can have basically you can have an error out if it can't find the environment variable and whatnot. So basically I use that if I need to pass that to my run function, right? In this case, that would be the approach I take, as opposed to having a specific getM function. And the same thing too, like for my tests, I'm initializing sort of a config struct specific to my tests. If it doesn't need to be specific to a particular test, I put it in test main. If it needs to be overwritten on a particular specific test, I initialize one there. So I'm able to control a lot of things about my environment, not just one environment variable, but like the entire configuration set, right, for that particular run of whatever I'm testing.
Yeah. So a similar kind of idea, really. And yeah, passing things in, making it deterministic. As I was saying, Roberto Clapis told me, because I used to do it with random numbers, same thing. So you just have a function that's going to return a random number. In production, you use the real crypto random thing. In your test code, you pass a new function, and you can just return the deterministic numbers. And Roberto made the point, well, if in production your code is dealing with random stuff, maybe in your test code it should be as well. And then I started experimenting with using actual real random numbers, which you can sometimes do, and depends on the case, again, as usual.
So graceful shutdown. I remember, maybe this is an artifact of having been around, having seen the evolution of these things, throughout the years. But graceful shutdown used to be when finally the HTTP library allowed for you to have graceful shutdown. That wasn't always the case from day one, right? When it finally allowed for that, that was a pretty big deal. back in the day.
Yeah, I remember that too, because there were you'd have to sort of do it yourself. There were a couple of packages as well.
Right.
Yeah, a friend of mine, Tyler, wrote one of those packages that was popular. And then, they added it. I think, so we mentioned earlier in that run function, you pass a context in. Normally in main, and this isn't really, I don't know if this is covered in the blog post, but I usually use the notify signal, which is actually, you can get a context to cancel when a certain interrupt signal has come in. So in main, I'll usually do that. And then that context then is cancelable by Control C or whatever, which is what you want. That doesn't end the program now because you've trapped the signal. This is in the blog post, by the way. It's in the func main only calls run section. So you essentially can cancel that context in your test code. So normally I would create a context with a cancel, defer the cancel. So I know that when the test code exits, it cancels that context and everything can get shut down. So if you spin up Go routines and you do extra things, this is like a main context that runs through your whole program. It's not a per request context, which is what context is really meant for. So some people saw it as an anti-pattern in the beginning. It's not a per request thing, but it's kind of, if you treat the program run like a request, in a way it is. If you treat it like run a program and get a response from it, then this kind of is that. But in a way, it works anyway. So you pass this context all the way through. If you're spinning up Go routines, check that main context all the time so you can cancel it. And then you make also new contexts off this one so that if this gets cancelled, they'll cascade down and they'll all get cancelled. And that's really a nice way to just kind of gracefully shut down really anything. You're sort of programmatically doing it using the context.
Right. I remember having to write a lot of signal trapping code and everything else. But I think you've taken a slightly different approach by using wait group for this. Let me see the part I'm thinking about.
Oh, it's in the new server bit at the top.
Right. So you initialize HTTP server, you launch a Go routine with the listen and serve, and then now you have a wait group with when you're listening for that context done before you can shut down things. Yeah.
This is after we have, if we have like a proper shutdown method that you call on the server, then you kind of you don't just want to cancel the context and then everything's done. You kind of want to wait for the things to be shut down. You don't want to just interrupt things. That's why it's graceful shutdown. You're waiting for things to finish, including like an in-flight request. That's the cool thing about this. You got a request that's come in, you've interrupted. Normally, that would just kill that request. It would crash. I don't know what would happen. Not good things. Now, if you do the interrupt, it'll finish what it was doing with that request. It won't accept new requests because context's been cancelled, and I think the HTTP server's smart enough to deal with that. And it'll finish anything in flight. And then you need a way to know that thing's finished. And I think it's the shutdown returns. So that's the signal. But so the way to do that in a sort of concurrent way is wrap it in a Go routine and one way to do it is have a wait group and then just wait for that one thing to be done. And you know that the server's not running anymore. It also lets you pass in a shutdown context with a different timeout. So you can say, right, I'm going to give you 10 seconds to basically shut down. Yeah. Right. And then if that doesn't happen, that context gets cancelled and it'll force the return. And then we say we're done regardless. So you're not going to wait and let it, imagine a request just hanging forever.
Assuming that none of your requests that you're still processing at the time of shutdown take more than 10 seconds, right? You have this maximum, right? Sort of amount of time you're willing to wait. Would there be a situation where maybe the whatever that last request is that's being processed is really important and maybe it takes 15 seconds where normally it would take 5, but it takes 15 and it's a really important request? Does that just get dropped on the floor then?
Yeah, I guess you've just made that decision. And it's really how long are you prepared to wait for things to shut down. You'll pay this price possibly, assuming things are hanging. If it's healthy, everything just shuts down immediately. But if there is an issue, you might well pay that price. And imagine in test code if you were paying that price every time. I don't think you'd be happy with that. But you probably won't. So yeah, it's just how long are you prepared to wait. There's another thing I did once that worked quite well, which was you trap the signal and that would cancel the context. And then you would have a new one waiting for another signal. And if you get the second signal, then you actually just do an OS exit. So, because that's quite nice behavior, sometimes like almost like a forced quit. Yeah, that worked too. I don't know if I did that with the signal notifier or if I did that manually. I can't remember. But it's not in the blog post. It's just a little bit of bonus material you get because you've listened to this.
Ian, what else is striking you about this? I'm seeing encoding, decoding in one place, which all makes sense to me. Validation, that makes sense to me.
Again, I think there are frameworks that some people prefer. The validation bit in this is just a nice, simple Go interface, and it just implements a method called valid. And in the encoding, in the decoding, and in encoding actually, before you encode, you can just check to make sure it's valid, and if there are problems, you can deal with it. So it's nice again because it's just Go code, but maybe you've used other things that you prefer. There are a lot of validator libraries I've seen.
Yeah, we do something similar with this validator interface, but ours returns an error. And after seeing yours, I'm like, I kind of like this map string.
More than one thing could go wrong?
Yeah, and I mean, we have like an error type that's literally like multiple errors for multiple fields, and this seems just so much easier. I might.
Wait, you have a single error struct that has all kinds of different errors possible within it?
Yeah, like a multi-error type thing. Yeah,
I see.
An array of errors.
You can say, hey, this field had, basically it's a map to a string, which is the field name, to another error.
I see.
Right?
Yeah, I used to do it like that as well. And it was just the dealing with it, just the unpacking it. You just had to know what that error type was.
Mm-hmm.
Or they usually have helper methods. And this really comes from trying to be minimalist, honestly. If I can get away with just providing one interface, that's better than an interface and a couple of helper methods. None of it's the end of the world. It's just to sort of tend towards minimalism. And yeah, I think returning the problems, just a map string. It's also nice. It's a sort of user experience thing. It's nice to tell the user which field has gone wrong. In the UI, often they can line it up in visually so that the error actually appears next to the field. Things like that, which you can do in other ways. But again, map string is immediately JSON encodable, where errors, again, it's more work there. So
if we needed to handle sort of localization, you just return some sort of keyword that they can then swap for whatever the appropriate language text it should be or something.
Good point. Yeah. I've seen it where it returns English, but then there's a map where the English key is it.
So the actual statement itself is the key for the lookup for the other.
Yeah. But then you change something and you get, you're in trouble there.
And it's broken.
You add a period and it's broken. Yeah.
Right. Exactly.
But then the test code would
help you cache that.
Yeah, because in that, yeah. But I'd probably prefer a key or even something with its own type, just to make that really explicit that that's what this is.
Yeah. Localization work is actually not trivial. I've been in the receiving end of that task. It's not.
Yeah, but you speak three or four languages. Imagine having to deal with localization and you only speak one language. It's a kick in the face. It's a slap in the face.
It's a slap in the face, isn't it?
Yeah, a little bit.
Yeah.
So the blog post doesn't go into it, but do you have like a standard way you're handling errors and translating to status codes and error messages, that sort of thing?
I've solved this a few different ways, and none of them particularly stood out as worth like getting into the post. It's just sort of slightly painful each time, but in a way, I think that could be quite comforting for people. Have you done it?
Yeah, that's why I asked, because it's painful every time.
Yeah.
Like I've tried probably 3 or 4 different ways at this point, and none of them are standout. Right.
Which is your favorite way?
That's a great question. Right now, we use just like an error code interface that our errors implement that return a specific code. And then each endpoint has its own switching on that to determine statuses. And because we run into the issue, we got nil back from the database for this object. That's a internal server error on this endpoint, but that's a bad request on this endpoint, right? So we've got to the point where like basically each endpoint declares its own like known errors that map to a status and a specific error message and return unknown for the rest.
Yeah. I've done things before where I have a special type. I also changed it to a wrapping thing when the wrapping all that kicked off. wrapping your errors, which you can do. You can have a type. You can just have a function that says like basically add this status code to this struct, to this error. So and then you wrap the error and pass it in. That's okay, but you end up with HTTP stuff in lots of different places sometimes. So I do try and solve that only in the handler itself, because that's the HTTP bit. So that's where I would do it. If you want, I don't like the idea that I've got some service that's nothing to do with HTTP, it's just its own thing, and it returns an error at one point, and then there's like a 500 or an HTTP status bad request there. Feels like the wrong place for it. I just wouldn't expect that to be there. So I feel like it'd be hard to find later.
You mentioned that, and that's actually how we do it. So the HTTP handlers themselves just wrap a generic bad request error that it knows it's a 400. But yeah, having HTTP related things in other pieces of code does feel icky.
Yeah, you just wouldn't expect to find it there, I think. It honestly does depend. Imagine if your service is explicitly dealing with HTTP stuff, or, you know what I mean? Like if the concepts are in your service, maybe you actually take the HTTP request in because you're doing something in the service, then then it is kind of polluted already, or it is just naturally dealing with that domain, and so maybe then it's okay. But yeah, if not, because again, imagine a non-HTTP world where you want to reuse that functionality, and you probably will. Even if you're doing things internally, like, you know, the other principle that I realize underpins a lot of stuff is it kind of prototyping and experimentation, and anything that makes things easier to kind of compose and hack around with and try things with, that's always a win, because you get so much innovation comes from that play, and that's how I innovate, is by playing around. So I enable that. I realize that's not how everybody does it, but if you're trying something and it's hard to try it, that toil, I mean, that's just going to get in the way, you know. So I always think, what's going to be easier later? What's going to give me more options later? And then I'll choose that.
Let's talk testing and testability.
Let's talk testing.
One of the sort of the decisions I remember making early on, and when working with HTTP services in Go, was to not bother testing sort of the routing or what the handler does for its work. Rather I would test the behavior that those things are relying on, and then expect that if I can make the behavior pass, right, then the job of the handler is to facilitate me getting to that particular behavior and getting the results that I'm looking for, but not really checking or testing that routing works. Because to me, I'm like, that's testing the wrong thing. I don't need to test the routers, because I know they're tested if I'm using, whether it's a standard library or some other thing. Like testing at the right level, I guess, is what I'm trying to get at. Like, what is your approach, or has it changed with this refresh?
My approach has changed over the years, because I love TDD. And honestly, I do TDD still. So I literally will write tests first. Now, sometimes I'll prototype things without any tests, but if I'm writing something serious, I do it because it helps me do it. It's like how I do it now. It's not, and I'm faster doing it like that. So it's not like a trade-off that I have to consider. It's just, I'm better off if I do it. So that being really strict on that leads you to overtest. Frankly, like in the beginning, you just overtest things. And by overtest, I mean either you're describing too much about how it's doing the thing, like you say, Johnny, not just what's it doing, like what's the behavior, but how is it actually doing it, and being too much in that business. Then when you want to change how it's doing something, all your tests suddenly need to change. And then the toil there is just like extra work. And I don't know that you get the benefit. I don't know that the benefit's worth it sometimes. You can also overtest. Yeah, well, they end up with that way. It's very brittle. You can also overtest where you really, any changes you make, or if you're adding things, the toil to then actually match the patterns that are established becomes so great that you're doing a lot of work for the sake of it, really, and you're not getting the value for it. Or you repeat the same thing in lots of different places in slightly different ways. If you've got like an integration, like an end-to-end test, that you say you're going to create a user that's going to then create a blog post, you know, you might have test data that's posting to an API and then checking the blog post. And then in the unit test at that layer, you're doing the same thing. You have a user, you're calling a thing, you probably stub a database. And, so I used to be very strict about testing layers properly like that. And then I settled on treating, this came really from something Dave Cheney said, which is that the unit, in a way, in Go is the package. Like, think about what the unit is when you're unit testing. And I was thinking the unit sometimes in these, well, you could say that the whole service is a unit, like a service is a unit. You can look at it like that. And so you essentially have end-to-end tests that they do test the routing. They actually test everything because you're literally running a real instance. And with Go, this is achievable because the compile time's so quick. And this is how we do it on at least one of the teams in Grafana Labs. You have, I just write end-to-end tests. I'm hitting, usually it's an API level. I'm hitting an API. I'm going to create, I'm just usually speaking in the same language that I expect the user to speak, whether that's the browser or someone actually consuming the API. And this is about, trying to be similar to what they're already going to do. So literally you have to solve auth in some way. Normally I'll deliver a client for the API as well, and I'll tend to use that in the tests. So you're testing the client at the same time. It really is end to end. You spin up real database. It's testing to make sure that the migrations in the database work. Everything has to work for these tests to pass. And that's also the criticism of them, because unit tests, more traditional unit tests, give you laser pointer to when something's broken. And that's really helpful. If something breaks in the auth, all of your integration tests are going to break. But they'll all break saying something's up with auth. So it's still quite clear. But
I don't think I trade off. Or rather, that trade-off is so sort of small to me that it doesn't really feel like a trade-off, right? If I can test basically, end to end, like if auth is broken, whether it's this particular test or that particular test, I'm going to get the signal. So I may not have a unit test specifically for that specific branch in the authentication process, but if I have enough coverage in my test, something is gonna tell me that, something is wrong, and it's consistently showing up. It's auth. I mean, it doesn't take me long to figure out. I know where the problem is, right? So to me, that trade-off doesn't seem like it's that big of a deal.
Yeah, that's a fair point. That's my experience too. It's just the argument against these sorts of tests, or one of the arguments is that you don't get so much laser focus. But and I also run the whole test suite all the time. Like every time I make changes, I just have the tests just run again. Because if they run quickly, you can really do that. But if I have if there's a bit of business logic that is a bit hairy or a bit complicated, then absolutely I would have a unit test for that. But what I wouldn't unit test is the handler that is decoding some JSON, calling another function, getting the response, encoding the response. Like that thing, I like the end-to-end test to just cover that. If anything's wrong in that, it'll fail, and that's great. Sometimes also, if you test it as a unit, you're passing in, you might have a different object that you're passing in, or you might just use a string to build some JSON or something. That's kind of less real in some ways. It could be less real because that request body isn't being if it's created from a client or something that you control, or that you it's official. That's just a more realistic test. So there's a few other examples. I can't think of any, but there are a few examples where you get a false sense of security from the unit test because the unit tests pass, but it doesn't work in production because routing's off, or something else that you just would never think of is off. And so you end up having those end-to-end tests anyway. So why not only have them? But this does depend for sure.
Yeah, I see a good argument for the end-to-end test too. Otherwise, if you're depending on middleware, you're depending on path variables, like that kind of thing.
Yeah, middleware's the other one. That's a good point. You can just call the method directly if it's a handler, which is really good sometimes, honestly. But you are skipping all the middleware bits, which, that might be what you want. But imagine if that middleware is doing something that's significant, it does a call out to find out the org ID and injects the org header. That has to work for your whole thing to work in production. And you could easily have tests that just don't catch that.
Yeah. We do authentication in our middleware as well. So it's a good spot to catch security issues.
much of these practices you've sort of enrolled into a separate Go package. I remember when you made that public, Auto. Do you still use Auto? Is Auto still part of your workflow?
Yeah, it is actually. So this is a dead simple idea, and it's a bit like gRPC, but gRPC is extremely powerful. There's loads of tools to learn. There's new languages to learn, protobufs. Companies like Buff are helping with that, and honestly, I think it's really promising, like the future of that. But Auto was the idea as you describe your service just using a Go interface. So you're taking a request object, a response object is what you return, and it's just methods in an interface, and that's how you describe your service. So nice that it's written in Go, and then there's a parser which understands that, turns that into new structs. The kind of meta that describe you've got a service, they have this many methods. Each method has input and output object. The object is described like this. It has these fields, these types. So it's just like uses the AST thing. That package in its own right is useful. It's the parser, which is a separate package. You can just use that to read Go interfaces. It's actually dead useful for loads of different use cases. And then it uses code generation with some templates to basically turn those service definitions into everything you need to actually have those services. All the gubbins, all the plumbing, everything is wired up for you. And you end up with just having to implement the interface. And that's your service implementation. So that was, and it follows, what the thing it generates, the HTTP side of it all follows all these practices. Yeah, that gets used. People use that because if you don't need more than that, if your case is quite simple, it's probably the simplest way to just do that. And any code gen is like a massive multiplier in productivity. We have template, the repo already has templates for Go client, Go server, TypeScript client, Python, I think, may have Rust even. So yeah, you can just generate the clients you need. So it's kind of like, and there's also one for the Open API spec. So you can generate, the Open API spec from your Go interfaces, and then you can generate all the things you can get from Swagger, or you can use more templates to generate docs that look nice, unlike Swagger docs, which are a bit of a red flag, honestly. If I see a website that's got Swagger, just the default formatting on it.
Nice. Ian, are you still here? Did you go get another protein bar or something?
Yeah, it looks jacked. Oh yeah, protein break.
Protein break.
gotta get that creatine.
Oh man! Anything else you want to call out, Ian, before we transition to unpops?
Not really. I want to check out this Auto. I had not seen it before. I love the idea of just generating like the boilerplate code that you can get wrong.
All right. Well, let's do it to it.
I actually think you should probably leave.
All right. Who's got an unpop?
I've got one.
Please.
I think this might be unpopular. We say like, don't bring patterns from other languages into Go, learn how to write Go. And I think that is great advice. But my unpopular opinion is sometimes it's okay to bring patterns from other languages if they're appropriate. And, why not? The reverse is also true, and I've lived this because I used to do a lot of JavaScript, TypeScript code. The JavaScript and TypeScript I write today now, because of Go, is minimalist, very simple, doesn't use a lot of the fancy language features. If it's going to be a function, it says the word function. Call me old-fashioned. Mm-hmm. But it reads kind of like Go code. It just turns out to be very easy to deal with for the same reasons that simple Go code is easier than fancy, amazing, you put a semicolon here and then that means this is blue instead. But if it's got an 8 near it, you better hope the moon's in the right orbit because you're in trouble. You know what I mean? It's like all this magic, mystical language features that are amazing. They feel good to use them, but just rather not have them.
Perhaps piggyback of my unpopular opinion. or to piggyback off of yours, I think we as basically the programming community, we will create those fancy, languages and fancy ways of doing things within those languages. And we'll even bash other languages for not having the fancy ways that we now do things, because of some other language or whatever. We're doing all of this in a way optimizing for the writing of code when most of the time we're just reading the code.
Yeah.
So it's kind of like counterintuitive, right? Like we're talking so much about, I can't be as expressive as I want to be with this language. And then you just write it once and then you have to maintain the darn thing like forever. And then,
that's so true.
We're silly.
That's because I think it's just more of a conscious act that we're writing. So it has more importance. It's also where we put a lot of more focus, and reading is a lot easier, but you're right. Reading's what we do way more than writing. Any code, like genuinely any code, it's going to be, I think I'd go on record as just saying that any code is going to be read more than it's going to be written. So optimize for reading. What's easiest to read? What's the simplest? What's the most boring? It just pays dividends. Say it like it's just a taste. It's just like a personal taste thing. This actually impacts productivity at some point. I mean, it's like proper serious. Like people should really think about this when they write code.
Any code I've ever written where I felt real smart while I was writing it, when I read it, I've never felt more stupid.
It's the same side. It's the opposite side of the same coin.
Right.
Yeah.
All right. Ian, you got something for me?
I really don't.
Man, okay. Unpopular opinion. Ian doesn't bring enough unpopular opinions to the show.
That's true. Like, I have opinions. They're just going to be popular.
Ian's like, I'm just that kind of guy,
I do think I hold the most unpopular opinion ever said on this show, though.
What, by the stats? It wasn't about me.
I think it was a long time ago. No.
If it was about me, I'm going.
I think I said something along the lines of promises could still be, like, a promise type pattern could still be useful and go.
Oh,
and I maintain that.
I'm with you, actually. I'm actually with you on that one. I don't hate it.
There's certain times where I just want to wait for something to be ready and then use it from then on. And
yeah,
I mean, that will still be unpopular. I guarantee.
Yeah. Mm-hmm. The error handling gets funky in it a little bit, or can't it? Mm-hmm. But to be honest, like if you build an API where you've got work that's going to happen asynchronously, and then you're going to come back later, that is a promise API. You probably, when you make the request, you get a response, and then you can periodically check to see, so you have that anyway, like as a pattern. So in that world, if that was your design, it would make sense potentially in some way to model it like that inside. I don't know.
It's not often I want to reach for that, but every once in a while.
Well, isn't it because every once in a while? So, all right. So let me not bash your unpopular opinion. Let me counter it with my own. Right. I would argue that the parts of the language, right, if you're not using, right, the parts of a language enough, or rather a pattern enough, if it's not useful, right, on a regular basis, then that in itself tells you something. That is a signal, right? It just means that most of the time, Yagni.
I don't reach for sync.const every day, but every once in a while, I really want to use it, right?
But is the cost of you bringing in that seldom used, right, approach, right? Is the cost of you, I mean, I use const all the time, so I don't share that particular opinion, but if the cost of you bringing in some particular way of doing something, right, and having to remember, and every time now you're reading that code and having to remember, okay, well, what is this doing again? And you have to think about it because it's not something you see often. It's not common practice. It's something different from everything else in the code base, right? Like there's a cost to that too, right? And if we're talking about productivity cost, right?
Of course, but if the Go code's like idiomatic enough, like where you're waiting via a channel and a select and all of that, like I think it's pretty easy to recognize what's happening.
Yeah. Do you want to be able to say like var something equals go some function call, and then but what's the point? It might as well just do it synchronously.
No, what I want is what I actually, I don't know. I've developed this as time gone on. And what I actually want is like a latch. So something that is open to start and then it closes once and remains closed forever.
Yeah.
Right.
I don't know that this could be a standard library thing, like that thing, the sync can't. Hard to say. You use that every day, Johnny? Did you say?
No. Or is it? Every day I'm using sync. No. I thought you meant const. The const.
Sorry. I thought the sync cond. Isn't there?
Not sync const. Sync con. Yeah. Very rarely do I use that.
You can't. Hang on. We can't broadcast this in the UK with that. That's not broadcastable in the UK. That's got that sentence you just said, Johnny, will mean we have to put the little explicit box on the podcast episode. The little E.
Really?
In the UK, I think, yeah. Just because of what that
sync cont or const.
Yeah, just be careful, mate. That's all I say. It's walking a line. They're walking a thin line.
A very thin line. Okay, all right. Well, if for my UK listeners, it is an honest mistake. It is just a language thing, I guess. American English, and whatnot. But it's yeah. Let's move on from that, shall we?
Let's move on. Sync cond.
Sync cond.
Yeah. By the way, I was convinced by Johnny immediately. I don't think it should be a language feature. I was imagining a type that you can have you could return.
Oh yeah, I don't think it belongs as a language feature.
Yeah, okay.
But as a type, it's nice.
There you go. That's what we mean. I don't think that's going to be so unpopular. Ian, why don't you, as a personal mission, get that added to the standard library? Remember, it's just open source. Anyone can contribute. Why don't we have sync.promise?
Sure. I mean, I'll give it a go.
I bet so.
I don't want it to be called that either.
Oh. No, what do you want to call it? Ian?
I like the label latch.
Latch.
Yeah, that sounds very go.
Where it's something that...
Oh, we need something sexier than that.
I like your suggestion, Johnny. Ian. You can't just name a feature after yourself. Although, quite a good idea.
Sync.Johnny.
Let's put an Ian right here. Sprinkle a Matt there.
No, but we could have a sync.obligation, couldn't we? Or a sync guarantee.
Obligation.
Yeah. Sync commitment. Could do that.
Sync commitment. And you can just say, I'm afraid of synchronized commitments.
What about a pledge? A sync pledge. I
kind of like that. I'm not going to lie.
Pledge.
A pledge.
There we go.
Oh,
yeah, I just want a piece of memory that's not ready yet and will become ready.
Yeah, and you can check it. You can block on a channel until it's ready. Come on. This type writes itself. It doesn't. Someone's going to have to write it in.
I have an implementation of it.
Do you? Is it in a repo? I mean, not a repo. Is it in like a public repo?
I think I have it as a repo.
Do you pledge to submit this? Har.
It's good. You just periodically check Johnny with him and see if he's finished. Or wait, block on a channel.
Get block, yeah. Are you looking for that repo, Ian?
I'm trying to find it.
We'll put it in the show notes for those who want to see it. I don't. I don't want to see Ian's pledge.
That's another thing you could do is just pledge.discard. Like it can finish or not. I don't care. You just clean up all the apparatus for checking. I don't know.
Is it really a pledge if you can discard it?
It's a good point. Well, you can fail a promise. Yeah, it's a pledge. Yeah, well, a promise. It's a promise. You can still break a promise.
You can still break a promise. Yeah.
That's why it's good, because it can fail.
Okay.
That's why you have to catch. If someone... That's why the JavaScript thing works so well. If someone breaks a promise, you have to catch it and then deal with it. What? It breaks down at that point, doesn't it? It's like, I'm going to give you a promise. Okay, good. And when this is done, then you can say, then something else. Okay.
Right.
Yeah.
Well, this was fun, wasn't it?
Didn't sound fun the way you asked that, Johnny. Didn't sound like you've been having fun.
No, I was trying my. Did you catch my sort of linguistic?
I catch the init
tidbit there. Yeah. You caught the init.
Yeah,
you caught the init.
I did.
I'm trying to incorporate that into my sort of everyday sort of vernacular.
Yeah,
and see if anybody notices.
Yeah. To be honest, initially I didn't notice because to me, that's just talking. Do you know what I mean? It's the rest of the stuff you say that sounds weird. That's the bit I was like, that just felt normal. No, it's every other word that I've got a problem with.
Every other word. All right. Fine. Before you have more problems with my words.
Oh no, that's not a good look for me, is it? He's ended the episode. Oh no, I'm ruined. I'm done for.
Let's end on Matt's bad note.
That is Go Time for this week. Thanks for listening along. Subscribe now if you haven't already. Head to gotime.fm for all the ways, or simply search for Go Time wherever you get your podcasts. You'll find us. Hey, do you receive our changelog newsletter each Monday? If not, let's fix that bug. One reader calls it so good, he considers it a competitive advantage. Sign up for $0 at changelog.com/news. Thanks once again to our partners at Fly.io, to our mysterious beat freak, Breakmaster Cylinder, and to our friends at Sentry. We love Sentry, you might too. Use code changelog when you're signing up for a team plan and save $100. Why not, right? That is all for now, but we'll talk to you again next time on Go Time.